Example 5. A curve has equation y is equal to ax plus b over x squared. Given that dy dx is equal to 0 and the second derivative of y is equal to a half when x is equal to 2, find the value of a and b. The solution. We know that if y is equal to ax plus b over x squared, this can be expressed as a times x to the power minus 1 plus b times x to the power minus 2 from the laws of indices. Then the dy dx or y prime of x is equal to minus a x to the power minus 2 minus 2b x to the power minus 3 when we differentiate. Then we are going to find y prime of 2, substituting for x by a 2, so that we have minus a times 2 to the power minus 2 minus 2b 2 to the power minus 3, and we equate that to 0 according to the question. With that, we simplify what we have so that we have this kind of problem or situation or equation, to be precise. Now we move on to clear the fractions by multiplying throughout by 2 to the power 3 or simply 8. In doing so, we are going to get a minus a minus b is equal to 0. Then making a the subject of the formula, we are going to get a is equal to minus b. Let's label this equation 1 for ease of reference. And also, we know that the second derivative of y, which is given by d dx of dy dx, is simply differentiating y prime of x. And we know what the y prime of x was, minus ax to the power minus 2 minus 2bx to the power minus 3. So we differentiate the terms individually so that we get the second derivative or y prime prime of x as being 2ax to the power minus 3 plus 6bx to the power minus 4. Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we'll be looking at the differentiation, especially the introduction to the second derivatives. This is part 5. I encourage you to check out all the other parts from the differentiation playlist, part 1 to part 4. And also, I encourage you to check out other playlists as well, as they could be beneficial to you. Now, we jump on to the second derivative. You would recall that if y is equal to f of x, then the dy dx or f prime of x is the first derivative of y with respect to x. And note, differentiating dy dx with respect to x again gives the second derivative. Now this is how we would find it. We find the d dx of the dy dx that we have obtained in previous videos. Now we denote the second derivative as either this or f prime prime of x. And note, the second derivative is not equal to the first derivative squared. These are two distinct situations. Now, let's dive into the first example for the day. A curve has equation y is equal to x cubed plus 2x squared minus 4x plus 6. The first part, show that dy dx is equal to 0 when x is equal to minus 2 and x is equal to 2 over 3. B, find the value of the second derivative when x is equal to minus 2 and x is equal to 2 over 3. The solution. So we know what our y is. So in order for us to find the first derivative, y prime of x, we simply differentiate the terms individually. That is to say, d dx of each and every term in y. In doing so, we are going to get y prime of x being the dy y dx, which is equals to 3x squared plus 4x minus 4. Then the y prime of minus 2. What we are doing here is substituting 4x by a minus 2. So wherever we had x, we're now substituting a minus 2. This would be 3 times minus 2 squared plus 4 times minus 2 minus 4. Now simplifying this further, we see that y prime of minus 2 is equal to 0, and that is shown. Then for the y prime of 2 over 3, we consider the y prime of x. So wherever we have x, we substitute that with the 2 over 3. So in doing so, we are going to get that. Then simplifying this one further, in evaluating, we see that the y prime of 2 over 3 is equal to 0, and that is shown. Now, let's consider the b part. We have obtained the y prime of x. Then, in order for us to find the second derivative, we need to differentiate the first derivative, y prime of x, or dy dx. In so doing, we are saying y prime prime of x is equals to d dx of dy dx, and that is the d dx of the y prime of x, which we obtained earlier on in part A, which was 3x squared plus 4x minus 4. So we differentiate the terms individually. So doing that, we are going to get 6x plus 4. So that is our second derivative, or y prime prime of x. Now that we have obtained our y prime prime of x, we now substitute with the minus 2. That is how we get the second derivative, or y prime prime of minus 2. So wherever we have x, we substitute it by a minus 2. In doing so, we are going to have 6 times minus 2 plus 4, implying that the second derivative of minus 2, rather y prime prime of minus 2 is equal to minus 8. Now, let's move on to find the y prime prime of 2 over 3. So we use the same y prime prime of x, but now we are substituting the x by a 2 over 3, so that we have this 6 times 2 over 3 plus 4. And evaluating further, we are going to get a positive 8 this time around. So that is how we solve for the first question. Now let's look at the second example. Given that f of x is equals to x cubed plus 2x squared minus 3x minus 1, find f of 1, b, f prime of 1, and c, f prime prime of 1. So we know that the question is asking us to find the first derivative and the second derivative in b and c. The solution. Now we know what our f of x is, implying that f of 1, we are simply going to substitute 1 in place of x. That is to say, f of 1 is equal to 1 cubed plus 2 times 1 squared minus 3 times 1 minus 1. And in doing so, we get f of 1, which is equal to minus 1. That solves the first part. Now we dive into the second part. If we have f of x is what we were given in part A, it implies that we can actually find the first derivative of x, rather the first derivative of f, that is f prime of x, by differentiating each and every term individually in f of x, so that we get 3 times x squared plus 4x minus 3. Then, in order to find f prime of 1, we simply substitute. Where we had x, we substituted by a 1. In that case, we are going to have 3 times 1 squared plus 4 times 1 minus 3. Now, f prime of 1 is equal to 4. That will be our answer. Let's dive into part C. So for part C, we need to find the second derivative. Now, this is f prime prime of x. So we find the d dx of f prime of x, which we obtained in part B. So in so doing, we are going to have d dx of 3x squared plus 4x minus 3. So we differentiate the terms individually once again so that we get f prime prime of x being 6x plus 4. Then in order for us to find f prime prime of 1, we simply substitute 1 in place of x. That is to say 6 times 1 plus 4. And this would give us the f prime prime of 1 being equal to 10. The second example is solved in that particular manner. Now, let's consider example 3. Given that y is equal to x squared minus 2x plus 5, show that 4 times the second derivative of y plus x minus 1 times the first derivative of y is equal to 2y. The solution. So we know what our y is. So what we would need to do is to find the first derivative, dy dx, and that is obtained by d dx of what we had as the y, x squared minus 2x plus 5. Now we differentiate the terms individually so that we get 2x minus 1. And also, we can find the second derivative by the d dx of dy dx, which was the first derivative, differentiating it again. So we know what our dy dx is, so that we have d dx of d 2x minus 2. Now, differentiating the terms individually, differentiating 2x, we get a 2, and differentiating minus 2, we get a 0. Now with that, it means that then, from the question, 4 times the second derivative plus x minus 1 times the first derivative. We know what these are. We simply substitute. So the second derivative was a 2, and we know what the first derivative was, 2x minus 2. We substitute for the first derivative and the second derivative so that we get that. Simplifying further, we are going to get 8 plus 2x squared minus 4x plus 2. Grouping the like terms, we get 2x squared minus 4x plus 10. Now we see that there's a common factor, a 2. We factor out a 2 so that we have 2 times x squared minus 2x plus 5. And take note, what is within the parenthesis or the pair of brackets is what was given as our y. So with that, it means that that whole expression that we were given in the question is equals to 2y. And that is also shown. Now, if this seems a little bit confusing, I encourage you to consult our previous videos, part 1 up until part 4, so that you fully appreciate what we have done in this series. Now, let's move on to example 4. Given that y is equals to 4x minus 2x minus 1 raised to the power 4, find the first derivative, dy dx, and the second derivative of y. Now, the solution. We consider the chain rule for the 2x minus 1 raised to the power 4 part. As you would recall, we would first let z be that part over there, 2x minus 1 raised to the power 4, because that would be differentiated separately and in a separate way compared to the 4x. Now, we let u be the inner function according to what we did in part 4, where we were, that was part 3, where we were looking at how to use the chain rule and the substitution method in order to solve such problems. Part 4 was about the tangents and the normals. So we let u be equal to f of x, which is the inner function, 2x minus 1, and the u dx being equal to 2 when we differentiate that u. Now we also have the z being expressed in terms of u. Since we have now substituted for the 2x minus 1, z would be u to the power 4, and the z du is equal to 4u cubed. Now, in order to find the dz dx, this will be obtained by dz du times du dx, And substituting for the dz du, we are going to get 4u cubed times the du dx, which we obtained in step number 2, which is step number 1, which is 2. Now with that, we are going to get dz dx of equal to 8 times 2x minus 1 cubed. Now great, then we have the dy dx given. We now consider the whole equation. So dy dx is d dx of 4x minus 2x minus 1 raised to the power 4. And differentiating the terms individually, we can actually separate them in this manner so that we get our dy dx as 4 minus 8 times 2x minus 1 all cubed. That is the first derivative. Now we move on to the second derivative, but we consider the dy dx that we obtained in the first part. Now we let the part that has got the cube be the v. So we are going to let our v be 8 times 2x minus 1 cubed. We could have let it be z, but I didn't want it to confuse some of us, so I'll just let it be a v. So in this case, it means that 1, we let u be f of x, as we did before. That's in the first step. 2x minus 1 and du dx is equal to 2. Then secondly, this would imply that v is equal to 8u cubed, and dv du is 24u squared, because what we have done is we now express v in terms of the u, and we differentiate v in terms of u, or with respect to u, so that we get 24y squared. Then this implies that dv dx is equal to dv du times du dx. We substitute for the dv du, which we obtained in step number 2, 24u squared, and the du dx, which we obtained in the first step, which is a 2. We replace the u, since we know what the u is, 2x minus 1, from the time we started the substitution method, step number 1. So this would mean that our dv dx becomes 48 times 2x minus 1 squared. Therefore, the second derivative given as d dx of the first derivative, 4 minus 8 times 2x minus 1 cubed, and differentiating the terms individually, we are going to get the second derivative as minus 48 times 2x minus 1 raised to the power 2. So that's how we get the solution. Now, we are going to jump into the final example. In the final example, a curve has equation y is equal to ax plus b over x squared. Given that dy dx is equal to 0 and the second derivative is equal to half when x is equal to 2, find the value of a and b. The solution. If y is equal to ax plus b over x squared, this can be expressed as ax to the power minus 1 plus bx to the power minus 2 using the laws of indices. And I encourage you to check the laws of indices video that we did. Then the dy dx becomes y prime of x, and we differentiate the terms individually so that we get minus a x to the power minus 2 minus 2b x to the power minus 3. Now, substituting for the x in order for us to find y prime of 2, wherever we have x, we substitute that with a 2. That would give us a minus a 2 to the power minus 2 minus 2b 2 to the power minus 3, and we equate that to 0 according to the information given in the question. Now, we simplify this one further. We are going to get this bit, which is a fraction, and we would rather clear the fraction by multiplying throughout by 2 to the power 3, or simply 8. That would give us minus a minus b is equal to 0. And solving for a, we are going to get a is equal to minus b. And let's label this equation 1 for ease of reference. And also, For the second derivative, we are going to differentiate the first derivative, dy dx, once again. Now, we know what our dy dx was. We substitute for that, and differentiating that, we are going to get y prime prime of x, which is equals to 2ax to the power minus 3 plus 6bx to the power minus 4. Now, in order for us to find the y prime prime of 2, wherever we had x in y prime prime, we are going to substitute that with a 2, so that we get 2a times 2 minus 3 plus 6b, 2 to the power minus 4. And we equate that to a half according to the information given in the question. Right, so with that, we are going to get this fraction, or this equation with fractions. Now, it is advisable for us to clear the fractions first. So, clearing the fractions, I multiply every term by the highest denominator, which is 2 to the power 4. In doing so, I am going to get 4a plus 6b is equals to 8. And I see that there is a common factor in all the terms, which is a 2. So I'm going to divide throughout by 2. This would give me a 2a plus 3b is equals to 4. And I'm going to label this equation 2. Now, we have equation 1 and equation 2. So in order for us to solve for a and b, I'm going to substitute for a from equation 1 into equation 2. In so doing, I'm going to get 2 times minus b plus 3b is equals to 4. This means that b is equals to 4. Now, substituting for b into equation 1, a is equals to minus 4. If you have made it thus far into the video, I say congratulations to you, and I leave you with the following task. A curve has equation y is equals to x cubed minus 6x squared minus 15x minus 7. Find the range of values of x for which both dy dx and the second derivative are positive. Your feedback, your questions are always welcome here. Make sure to like, share, and subscribe so that you don't miss out on any of our future uploads. Thank you so much for watching Numbers Simplified. God loves you.